Hi, so how is going? Have you figured out how to do this one? I hope I hope that you get it right. Okay, so if not, it's okay. Let's work it out together. So now we see this is a change in the kinetic energy. That should be whenever you see like in physics, they mention a change. This is just like the rule, okay? Whenever you guys say there's a change, what will be the symbolized as delta. This is also another Greek letter. Yeah, I know we borrow a lot of Greek letters in math and physics, and sometimes it's like confusing. So just learn it a little bit, and you will get familiar with it. It's like delta, okay? So that change look like a triangle, but we call it like delta. So change here will equals to the final minus the initial. Okay, so what does it mean? It means that here we would have the final kinetic energy minus the initial kinetic energy, and here we just want to care about the kinetic energy at this phase, right? From here to here. So this one becomes the initial. This one is the final, okay? We just want to care about that part. So then what is the final here? This is like just the two M together, right? The golden block and the bullet, zero, right? Square, because that will be the kinetic energy at the end. And what is the initial one? That should be 1/2 of the bullet and the golden block as well. I will move it a little bit here. Okay, yeah. And then this one should be the V, right? This is the V that we're looking for. We are trying to find it. That's our purpose, we are doing so far. And then we can see, oh yeah, for now everything just come to zero because this is zero, so this is zero. So what left? We just say, oh, I forgot a square here. I'm sorry, my bad. Square here, okay? And then we have this one on the left side, just left 1/2 of the mass of the bullet plus the mass of the golden block times with the V square. Okay, wait, so seems that we know these values, right? Like if you want to add some numerical values here, we can see this one should be like 1/2 of like 500 times 10 to the minus 3 kilograms plus 1 point. Okay, I should use the same color. That should be like 1.20 kilograms, right? That's what we had before. Times with V square is what we still don't know. And then on the other side, we have what? We have minus F. Do we know F? Seems that we don't know F either, but do we know S the displacement? Yeah, just keep calm. Let's just plug in what we know, right? So usually when you kind of like used to like solving the variables by the letter, you can just like rearrange them. But here I want to show you like step by step the logic thinking of how to solve the problem. So here, see, we know this value. We know this value. And again, we just have another equation with v squared and then f. Oh, seems like it's kind of like long problems, right? It's okay. Just patient a little bit. Can you find the kinetic energy? Because this is a logic, right? We want to find this one. So if we know this one, then we don't need to find it. So the logic is that we need to know this one first. So there should be some way for us to know this one. And then now it leads to another problems to find for the friction F. And yeah, you remember the equations, right? That's another equations. Yeah, physics is just like connecting many terms together. I'm sorry about that, but we will, like when you already understand them, you can just like combine them together. Just be patient and get used to it. So anyways, frictions here is a mu times with what? Normal force, right? Can you find normal force? Yes, right? Because here we see, based on the free body diagram, on the vertical, the forces should be balanced with each other, right? If they don't balance with each other, so just so you can imagine like the whole thing will just like jump, 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 jump like that along the way, and which does not happen here. They didn't move on the vertical direction, which means that these force vertical one have to cancel with each other, which means that n equals to mg. So I just have to say like you only have like n color really special when you have an incline, you know, like if you have an incline, then if you have the mass here, you have the weight like this, then you see that n always a normal to the surface this way. You see only in this case that you see that these two forces can never like cancel each other, right? Like the normal force is this way, the way this way, they can never like cancel each other because they're not in the same direction. So in this case, the normal force should like cancel out with some forces in the same direction with it. And actually, if I try to zoom in a little bit here, you can see that that should be just the component of the weight along that, like this one. And like if you know the angle of the incline, this is the angle of the incline, then always the normal force equals to the components of the weight, this one, which is the adjacent to this angle, right? This is the angle of the incline. So then you always have the very general equations that the weight times with cosine of the angle of the incline. Okay, let me see, this will be the let me move them a little bit here, that will be that the normal force time equals to weight times the cosine of the angle of the incline. Okay, but this is not our case. I just want to like remind you that sometimes you will get like, oh, I kind of like confused why sometimes normal force is this one, but why sometimes normal force just like equals to weight. Because you know what, different situations, right? So that's why whenever you do any physics problems, please draw it, sketch it out, then you will see, oh, it makes sense. So anyway, this is just like a bonus just to help you if you kind of like confused why we need this. Okay, back to our problems here. Here we just simply have what, we just simply have this one in our problems, that's mg, and we can find the frictions, right? You're right, yeah. So here you can just like tell them, show it to them that this one equals to n, and then n here actually equals to mg, right? This is good enough, yeah. And then do we have mu? We know that we have mu, right? Yep, mu is like 0.02. What is the, it doesn't have a unit, it's just a number, a coefficient. What is the mass here? Oh, the mass here is actually is the mass of the whole thing, right? Okay, so let me make it here more accurate in this way. That should be the mass of the bullet plus the mass of the block together. So we can have just like this whole thing's right here, right? This is the whole thing right here, we know that. I just copy that, then I don't have to write again, you know. I'm lazy, I know that. So this is the one that I just rearrange them like this. How about I bring them everything here like this? Then, okay. Sounds good? Sounds good, right? That's the mass. And then just the G, 9.8 meter per second square. Yay! So you see that we kind of done. We got the frictions, right? Let's just use a calculator. If you want to use a calculator, then we got the F. You see the logic now? Then after we got the F, then what we need to do, we just have to like plug it back in here, right? And then after we plug it back in here, then we will got the V. And then after we got the V, then we just plug it back in here. Then we can see, we can find this one, right? Right? Magic, right? Okay, so you want to do the rest? Okay, I let you do the rest. Okay, then maybe see you in the last video in order to see, okay, what is the final answer. Okay, thank you. Good luck.